how do fish live at the bottom of the sea? Well, bear with me for a moment, because these books are made of matter, or stuff. And so therefore they have mass, which is basically a measurement of how much stuff there is in each of these books. And as you hold on to these books in a hand, well, you start to feel how heavy they are. And that's because we're feeling the effect of gravity on the mass, kind of pushing it down here, which is really kind of heavy. So I'm going to set those there. And water, like books, is also made of matter, and so therefore has mass. And we can stack water a lot like we do with books in like an aquarium or even a water bottle. Okay, but let's see if we can figure out how this actually affects things. So we're gonna model something here. Poke a hole near the top of your bottle with a thumbtack, and then just make it a little bit larger by just wiggling that around. And then in the middle of your water bottle, and then at the bottom. And now we're going to use some masking tape to make little doors to cover that up. So we're gonna just take off a piece of masking tape and then make a loop on one end. And then you're gonna try and cover up each of those little holes that you made there. Now, which hole do you think will squirt water the farthest when you fill it up and let it go? Let's find out. So we're gonna fill up our bottle. You're gonna do this over a sink, or I guess an aquarium. Then we're gonna try taking off this top one. See how far the water squirts, kind of dribbling out there, right? What about this middle one? Ooh, that's going pretty far. What about the bottom one here? Whoa! Look how far the water's going there. That is really amazing. Okay, so water has water pressure made by gravity pushing down on top of it, which makes it squirt out. And we don't need a pump for that. We were able to do that just with gravity pulling down on the water, just like a stack of books. But do you remember buoyancy? Well, water doesn't just push down like a stack of books. It actually flows, so it goes all the way around whatever it is that's in the water. So take a plastic bag, put your hand inside of it, and then just stick that down into the water and watch what happens. All right, so we stick that down. Oh, do you see how it's kind of getting squished around my fingers there? That's because even though air does have air pressure, because it is also matter and therefore has mass, it is way less massive or less dense than water. In fact, 10 meters of water is equal to about 10 million meters of air, which is why the air was pushed up out of the top. But how does this affect fish? Well, we're gonna need to model that. But to do that, we need to move this tank. And it's heavy because there's a lot of water in it. So, hey, you guys! Thank you! Awesome. Okay, so now we're going to pull up a tray and we're going to start making a fish out of some Play-Doh. Yeah, this looks exactly like a fish. I'm just gonna put some little scales on it. And then you can take your toothpick and stick it down into the middle of the fish, because that is going to be the bones of the fish. They have a lot more than one, but you know, we're gonna start there. But then we're also going to make a blobfish, and that is going to use some water beads that you soak overnight. And you don't want to pour them in with water, so just kind of pick up a few. Oh, those feel so much fun. You're gonna put them into a plastic baggie. All right, and now you want to squeeze out any extra air that you have as well. You're gonna twist that up, and you're gonna add a rubber band on the top so that the things don't fall out of your baggie. And just like your little clay fish here, you could put a little blobby face on the front of your bag here. So I'm gonna do that, just kind of give it a nice little blob face. And now we need a plate here, all right? So we're gonna put those there. We're gonna put the plate on top of both of these. And what you're probably gonna wanna do is get down, kind of low so you can kind of see what's going on here. And then you're gonna start stacking books on top of it, right? All right, that's kind of hard to balance. I'm not pushing down, just stacking on some books here. Well, now we've got some mass pushing down on top of our fish. Kind of like water pushing down from on top there. All right, so let's see here. We're gonna take this off. Ugh. We're gonna take off the plate. And which one do you think survived the squish better? Oh my. Well, the blobfish seems very unaffected. How you feeling? Yeah, that's how I thought. Okay, but my other fish, wow, he has a giant slash down there. He got kind of squished down. So why did this fish get squished and this one survive just fine? Well, how do we survive? Well, we are under 1 atmosphere of pressure because, again, the air above us actually has mass, so it's pressing down on us. But you go just 10 meters underwater, and now you're at 2 atmospheres. Add another 10 meters, and now you're at 3 atmospheres, and it really starts to squish on your body. The more blobby nature of the blob fish allows it to handle all that pressure coming in it at all different directions, and it's perfectly fine. Whereas this fish and our bodies tend to get squished as we go. But blobfish only live at about 3,900 feet underwater, which is really, really deep. But the abyssal zone of the ocean starts at 13,000 feet underwater, which means that there is a lot of pressure there. But some very rare giant squid live at that depth. We can only live deep underwater if we go in special submersibles. I prefer to live up here in the atmosphere and sometimes going into the deep end of the pool where my ears start to hurt if I go under, starting approaching that 2 atmosphere depth. So, were your predictions right about how far the water would squirt out of your bottle or about which fish did better? How well did your fish survive in the deep water?